Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm James Titko. This week's question comes in from listener Jimmy. Why is new plastic flexible, but old plastic brittle? Well, Jimmy, thanks for this question. There are, of course, lots of different types of plastic. Some we want to be flexible, as in a plastic bag, or some we want to stay rigid, like a plastic bottle. To start answering your question, we need to understand what accounts for these different properties. And to help me, I've enlisted the help of Philip Broadwith from Chemistry World.
Plastics are polymers. That means they have molecules that are long chains inside them. If you want those polymers to be flexible, those chains need to be able to move over each other when you apply a force. They don't stay still. You can do that in a few different ways. You can either make the chain molecules branched and twiggy. That means they can't pack together so tightly, which means that there's a bit of space between them for them to move as you apply a force. Or some polymers, like silicones, have bonds between the chains, which change how rigid they are. If you think about silicone, you can have it as a kind of almost a paste or liquid when you squeeze your bathroom sealant out of the tube. But then as it cures, what's happening is there's more bonds being made between the chains. So the polymer gets harder and more rigid into a kind of rubbery state. But for the same polymer, if you take it even higher and make more links between the chains, you can make it into a completely rigid polymer. So that's called cross-linking. So the more cross-linking you have, the more rigid the polymer is going to be. The other way that you can do it is to add an additive called a plasticizer, which sits in between the chains and acts almost like a lubricant. There's lots of different types of plasticizer, but the most common one that people will encounter is in PVC. So if you think about window frames, they're made of unplasticized PVC. They're quite rigid. There's not very much plasticizer inside them. But if you think about softer PVC, like the fake leather that you might have clothes or furniture made out of, or things like Barbie dolls with its kind of soft PVC, that will have a lot more plasticizer in it.
Now, under our forum post on this question over at nakedscientist.com/forum, user Alan suggests that exposure to heat and UV radiation can change bendy plastics to brittle over time. Is he right to say that? And if so, why?
Yeah, that's exactly what's happening. Environmental conditions, heat, light, oxygen, all cause chemical reactions within the polymer. Those chemical reactions might break the chains down, which might make them more rigid or crumbly. It might make more crosslinks between the chains, which is going to make them more rigid. Or it might evaporate or leach out the plasticizer molecules. We had a feature in Chemistry World recently about preserving Barbie dolls, which are made of PVC, which has a plasticizer in, and they have all sorts of problems with the plasticizers coming out or the materials degrading. So if you want to then preserve those plastics, it's quite a challenge.
Are all plastics susceptible to this loss of bendiness over time?
Well, most flexible polymers will tend to become more rigid over time because they will age, but sometimes that's not the problem. Sometimes you can go the other way. The way the polymer degrades will make it more kind of sticky or more flexible in some ways. And there's quite an interesting story on that, which is in the 60s and 70s, there was a musical instrument called a clavinet, favorite of Stevie Wonder. If you know the song Superstition, that riff at the start, that's a clavinet. The hammers that hit the keys in that instrument, it's a keyboard, were tipped with a rubbery polymer. And over time, that polymer would become more sticky, and that changed the sound of the instrument. It went from a more hitting the strings to a slightly sticky plucked sound, which sounded slightly different. And there were various jazz musicians and some people who really preferred that kind of sticky plucked sound. So they would start to seek out instruments where the hammers are degraded enough to make that sound.
Chemistry and music history here on Question of the Week. Thank you so much to Philip Broadwith from Chemistry World and Jimmy for the interesting question. You can find links to some of the stories mentioned in this piece over on our website. That's nakedscientists.com. Next time, we'll be answering this question from listener Daniel. He asks, how do we know for sure that the laws of physics that humans have set down in ink are the same laws of physics that another civilization might have on another planet? That is one big question that I can imagine will spark quite the conversation over on nakedscientists.com/forum, and be sure to drop us a line if you have a question of your own. The address is chris@thenakedscientists.com. Until next time, from me, James Titko, thanks for listening and goodbye.
Question of the Week is part of the Naked Scientists podcast. Look us up online at nakedscientists.com.